Let's solve this beautiful radical equation. We need to find the value of x, where the square root of x minus 1 over x, plus the square root of 1 minus 1 over x, is equal to x. To make this easier to handle, let's use substitution. Let a be the first radical, and let b be the second radical. If we square both of these, we get a squared equals x minus 1 over x, and b squared equals 1 minus 1 over x. This means our original complicated equation simply becomes a plus b equals x. Now, let's look at the difference between a squared and b squared. X minus 1 over x minus 1 minus 1 over x. When we open those brackets, we get x minus 1 over x minus 1 plus 1 over x. Notice that the negative 1 over x and the positive 1 over x cancel each other out perfectly. We are left with a squared minus b squared equals x minus 1. Now we factor the left side as a difference of squares. A plus b times a minus b equals x minus 1. But remember, we already know that a plus b is equal to x. So let's substitute that in. We get x times a minus b equals x minus 1. To isolate a minus b, we divide the right side by x. So, a minus b equals x minus 1 divided by x. We can split this fraction into two parts, x over x, minus 1 over x. Since x over x is just 1, we find that a minus b equals 1 minus 1 over x. Now we have a system of two equations. A plus b equals x. A minus b equals 1 minus 1 over x. Let's add these two equations together. The positive b and negative b cancel out, leaving us with 2a equals x plus 1 minus 1 over x. Let's rearrange the right side just a little bit. We can write it as x minus 1 over x plus 1. Why did we do that? Because look back at the top. X minus 1 over x is exactly equal to a squared. So we can replace that entire term with a squared. This gives us a beautiful quadratic equation in terms of a. Let's bring everything to one side. A squared minus 2a plus 1 equals 0. This is a perfect square trinomial. It factors into a minus 1 whole squared equals 0. This implies that a minus 1 is 0, so a must be equal to 1. Now we go back to x. Since a is equal to 1, and a is the square root of x minus 1 over x, we can say the square root of x minus 1 over x equals 1. Squaring both sides removes the radical. X minus 1 over x equals 1 squared, which is still 1. Now, let's clear the denominator by multiplying the entire equation by x. This gives us x squared minus 1 equals x. Moving x to the left side, we get our final quadratic equation. X squared minus x minus 1 equals 0. To solve this, we use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Plugging in our values where a is 1, b is negative 1, and c is negative 1, we get x equals negative times negative 1, plus or minus the square root of negative 1 squared, minus 4 times 1 times negative 1, divided by 2 times 1. Simplifying the inside of the square root gives us 1 plus 4, which is 5. So, x equals 1 plus or minus the square root of 5, divided by 2. This gives us two possible values. 1 plus root 5 over 2, and 1 minus root 5 over 2. However, let's look at the original equation. The sum of two square roots must result in a positive number. Since the sum equals x must be positive. 1 minus root 5 is a negative number, so we must reject that solution. Therefore we are left with only one valid solution. X equals 1 plus root 5 over 2. And there we have it, the golden ratio. If you enjoyed this satisfying solution, please hit the like button and subscribe for more.